So we know now that a derivative of a function of one variable at a specified point is the instantaneous rate of change of the function or the slope of its tangent line at that point. That's what you do in Calculus 1. The two-variable geometric meaning is this. The partial derivative of f with respect to x at the point x sub 0, y sub 0 is the slope of the trace of the surface in the plane y equals y sub 0 at the point x0, y0, f of x0, y0. That's, the z value of the point. And this gives the rate of change of f with respect to x when y is held fixed at y sub 0. That's how I'd say it in words. Let me try it geometrically. We have a surface, f of xy, that's this, looks like it might be upper part of an ellipsoid, and this plane outlined in black is the plane y equals y sub 0. And this blue line is where that plane is intersecting that surface. Now, this red line is the slope of the tangent line to the intersection of the plane y equals y0 and our surface at the point x0, y0, I would call it z0, but z is f of x0, y0. So at this point, this is the slope of the tangent line to the intersection of the surface and the plane y equals y0 at this particular point. That would be the slope of this red line right here. Now, let's flip over and say, oh yeah, well what about a partial derivative with respect to y at that point? Well, in the picture, f sub y of xy, or the partial derivative of f with respect to y at xy, is the slope of the tangent line to the surface in the plane x equals x sub 0. So I kind of flip that picture around and say, here's our surface, here's the intersection, well, here's the plane x equals x0 outlined in black, and this blue line is the intersection of the surface and that plane, and the red line is the partial derivative with respect to y at the point x sub 0, y sub 0, at the domain point x sub 0, y sub 0, so at the point x sub 0, y sub 0, f of x sub 0, y sub 0, that's the z value. So the notation for the first partial derivatives, you can sometimes, it looks like a d, but it's not quite a d, or the f of x, I've already shown you that one. So here's one. This is another one, z sub x, which means the partial derivative of z with respect to x, or partial of z with respect to x, like that, depending on whether you're given the function z equals f of xy, then you might use this. Or if you're given just the function f of xy, you might use this. Or of course this is acceptable, and I hope you understand all that. And of course same goes with the partial derivative with respect to y. So now that you have a handle on the geometric definition, this should give you a pretty good handle on the notation of the partial derivative with respect to y. By the way, notice the word first partial derivative with respect to y. First partial derivative with respect to x. Yes, indeed, we will be talking about second derivatives as well. So the text puts the vertical bar on the other side to show like the partial derivative of f with respect to x evaluated at the point where x equals a and y equals b. I can't notate it that way with my software, but I will probably notate it like this. This is partial derivative of f with respect to x evaluated at the point AB, and this one partial derivative of y evaluated at the point AB.